All right, let's jump into the hard one. This is building a controller. I find these to be the most difficult parts. The math is there. There's a lot of checks though. So we've got our math figured out. We just need to subtract hit 1 from hit 2 and convert it to meters. Easy, right? All right, let's figure it out. So let's get back over to here. We'll find our controllers here, and I went ahead and I've gone ahead and I've made a subfolder in the controllers for a mouse. As we do touch controllers, as we add touch controllers to this, we'll put that into a different folder. As we add ZSpace stylus or other input devices, we will add more folders and connect up the functionality. On that, now let's not talk about that. So we're gonna do, okay, what do we call this? We're gonna call this drag tape body. And we're gonna do drag tape body dot test.ts. Okay. Bring this over here, close others, close others. All right, here, let's build out our class now. So we're going to do a class for this because there is state. Essentially, we're going to be dragging, and we need to do comparisons about where we were versus where we are. You could probably get clever and write this as a function, but it makes sense for me to have a state. I like states. Yeah, we're going to do a state. Okay, so here we go. Export class drag tape body. And let's have a constructor. Now I'm going to start using this thing. I have an entity inside of our domain called mouse input on scene. I'm not going to dive too much into that, but what it does is it collects up all the input events and the arrays, and you can use them and subscribe to these events from this entity. And that's how you receive, that's how the controller receives presses and drags and click events. That's how it gets triggered to do what it needs to do. So I'm going to add that in. So we got this mouse, I'm just going to call it input. And that's, what is that, scene? Mouse input. Scene mouse input, there it is. Let's see, what else are we going to need? Well, we'll start with that. And then we'll go from there. Okay, so let's go ahead and store that. Because we'll need to be, we don't need to unsubscribe. No, we'll have to pull things off of it. So we're going to do private input, and that's a scene mouse input. And let's just store that. All right, and we'll get that in here. This dot input equals input. All right, let's start writing tests. So let's start thinking through what we expect this thing to do. So first off, make our test rig, and obviously we need a scene mouse input, so we're gonna constant input equals scene mouse make scene mouse input. All right, that's great. We're gonna need our controller, and that's going to be new drag tape body. Now here's where I'm going to get confused, and I struggle a little bit. Am I writing a controller for a single tape? Like, is this tape going to be pegged to a specific controller, and it's going to start and die when that controller starts and dies? Or is it going to be a general one that we can apply to any tape? I think we're going to make it the latter. We're going to make it a general one, and we're just going to see if we can get an input on a tape body, and then we will go from there. Yeah, so that means this controller is going to stay alive. It's not going to come and go when tapes are added or deleted. It's going to stay in the scene, and so we don't need to. So we just need to build it that way. Okay. So Drag tape body, and we're going to get input. Jeez, that's a little bright, isn't it? All right. All right, so just thinking through this, guys. These are complicated. These are hard for me to do. Well, first off, we need to have some tapes in our scene because we're going to do a pick, and we're going to need to know if our pick hit a tape. Yeah. So let's go back to our view. We didn't really set this up on our view. The way we identify if this is a tape is we can add an attribute to a mesh called scene object ID, and we're going to do that. So what we're going to do is in our tape measure view, let me make sure I get the syntax right. There's going to be this thing called metadata. Here we go. We're going to do this metadata. We're going to add this metadata to our tape measure. Yeah. Do I just want to add it to the body of the tape measure, or do I want to add it to the tape? I think we're just going to add it. We're going to add it to everything. It's going to be fine. I think it's all relative. So this dot body mesh dot meta. You know what? Let's not do this one right now. Let's jump back for a second. We don't need to worry about that. We'll worry about that when we hook it up. So let's go back to our controller. Use case, not context. Where's our controllers at? Interface, controllers, drag tape body. Okay, so here we are. Got our test rig. Let's go ahead and kind of get our input device going. So the input, it expects to be told from somebody that the mouse has moved, and that's how it kind of starts. It expects some mouse movement before you get clicks. So we're going to go ahead and input.submit mouse move, and this kind of gives the mouse some position, gives this thing set up. So we're going to do a mouse ray of, we're just going to shoot the mouse straight down. So the mouse is going to be, in the real world, the mouse is going to be a little bit oblique, but that makes the math really hard. So we're going to pretend like our mouse is shooting straight down into the scene. So the mouse ray is going to be, we've got this class called a parametric line, and we're going to call it, we're going to do down. So we're going to make this mouse ray down. What else we got? Pixel position. This is not really going to come into play here. We don't need to calculate anything off the pixel position. We're going to do everything off of the raycast here. But it expects you to have a pixel position. So we're just going to do make vector 2, and it's going to be 0, 0. And I think that's enough to get our mouse ray going. Is there anything else we need in here? You know what? Let's go ahead and do over scene object ID. So this is what I was starting to get into. What we do is we put attributes or we put metadata on the meshes. And then when the mouse ray comes along and hits things, it looks for this particular attribute. And if it finds that, it's the scene object ID, and that's that GUID that uniquely identifies something. And then we can take that GUID, we'll get that GUID through here, or that identifier, and we can then decide if we need to take action or not, if we're clicking on the right thing. So this will help us see, are we actually pressing on the ground plane, or are we pressing on the actual head of the tape measure? So over scene object ID, let's go ahead and say tape 1. Let's stub that in there. And so we'll start out in the right case. So let's go ahead and make our tape while we're at it. So constant tape. Yeah, because we need to add a tape in there, equals make tape measure. And we're just going to call this tape 1. And we need to attach it to something. Doesn't really matter. And then we're going to we're going to constant tape measure tape repo. Is going to be make tape measure repo, and we're going to tape.add tape repo. We're going to add this tape to it. All right, now we got that set up. This is a nice little trick you can do, is you don't actually have to fill out and create the use cases. So remember in the previous video, we made the use case that moves the thing. We don't actually need the testing that. That's all been tested. We assume that that downstream stuff is done. We don't really care about it. So instead of actually creating that function with the factory and all that stuff, we're just going to use a jest test. So we're going to do a constant move drag tape use case. It's going to be equal to a jest function. All right. So there's our jest function. Now, a couple things I know. Well, let's get into this real quick. So test. Let's go ahead and do this. Test. We are going to do pressing on a tape moves it. This is going to be our first test. We're going to check to see if this happens. So we're going to check for press and drag, and that should drag that tape, should call that use case. So we are going to need, oh no, we're going to return these things. We're going to return, so we're going to fake the input. So we definitely need to have the input so we can apply presses to it. We're going to fake the input, and we're also going to watch this drag tape UC. So that's what we need for this first test for sure. So constant input and drag tape UC from the make test rig. All right, so that's the first thing. Cool. Now, here's what I expect to happen. We've set our mouse up here so that it's shooting down, and it's already over tape 1, which is the name of our tape. So what we expect to happen is if we do an input dot press or submit mouse button down, left button, and then we do an input dot submit mouse move, and we send another set of movement parameters into here. Let's grab these guys to start with. Too many squiggles. I know we have to change the pixel because otherwise it thinks the mouse really didn't move and it doesn't populate. If we do these two things, if we press and then we move the mouse without releasing, we expect the drag tape UC to be called. Don't really care what it's called with yet. We'll get into that in a second. But this is what we expect. I mean, this is kind of our first generic test is, well, we just expect it to be called. If you press on and the ray is already pointed, so the mouse ray is pointed at this scene object ID, which is a tape that we made, and we've pressed with the left button, and we've dragged, we expect the use case to be called. All right, let's get our test running. I don't expect it to pass. And it didn't. So let's get this started. So first off, we need to add some observers. This dot input dot on button let's see. Well, add mouse down observer. That's the one we want. So on this dot on mouse down. So let's make that in here. So we got this on mouse down, and I know what we do is we get a button, and that's going to be a button, mouse button. There it is, and we're going to send it into here. All right, that should take care of our mouse down. And then we got this dot input dot add mouse move, add mouse drag, I think. Add drag observer. This dot on drag. All right, and so that's another one. We got an on drag is going to be equal to this situation. All right. So first off, we need this use case. So let's go ahead and pass in our drag tape use case. And if you remember, let's go to our use cases. And look at the signature of that guy. Use cases, drag, tape, body. It's going to look like this. Drag, tape, body. All right. ID string to a vector 3, which is our vector 3, and it doesn't do anything. This. We need to store this use case function up here, so we're going to do a private and use case function like that. And this needs to go to a void, and then we'll store that here. This dot drag tape UC is going to be equal to drag tape UC. Oh, we forgot the void here. There we go. All right, so now let's just get this tape to pass first off, or this test to pass first off. We need this guy in here now. And we're just going to do it just a call. We're not going to do any tests or anything. We're just going to say this dot drag tape UC. We're going to call it with some ID and make vector 3 of 0, 0, 0. Cool. That might get us to pass. All right, it's passing. Now, obviously, this is not what we want. Press on the drag on the tape moves it. Let's do the next check. Test. Press on something that is not a tape. Does not drag. A lot of knots in there. But essentially we're going to do this. So what we're going to do is this. Previously, we were over something. Now we're going to do, before we press, we're going to say the mouse has moved, but it's over something else. Then we press, and we drag, and we expect this not to be called, because the thing that we're over is not a tape measure. Let's see if that passes. Kind of surprises me that it does pass. Oh, I probably did not. Oh, I know what happened. This is a little tricky thing I don't like. You got to make sure you bump your pixels or else it doesn't. It ignores it. All right, it did get called as we expected because we don't have any logic in here. So here's what we're going to do. Now we need to be checking to see if this guy is a tape measure, the thing we're over. So we need to grab our repo. So we need to have our repo, private tape repo. And this is a tape measure repository. This needs to be passed in on the constructor. Let's put it in here. And then we go like this. Okay. Now what we can do is we can check to see. We're going to add a little flag we're going to set here and say private is dragging is false. Now, on press, we're going to default this dot is dragging equals false because we're going to do a bunch of checks actually in here. But then we're going to do this. Okay, this dot tape repo dot has. I have a thing in here that says, is this a tape measure? Well, first off, we're going to do this. Well, this dot input dot last get. Oh, what is it? Get picked scene object. There. Okay. This could be undefined. So we need to do a check for undefined. If we're over nothing, dot, well, let's just put this out here. No. It's this. If not picked scene object, we return. We don't need to do it. We don't need to set our flag to true. And then we're going to do another check. If tape repo has scene object, picked scene object. If not, we'll return. Now we can do this thing, this dot is dragging equals true. Now down here we can come down, we can say if not this is dragging, we're out of here. We don't need to do anything. See if that worked. Type error. This dot, what? That doesn't seem right. Oh, you know what we did? We forgot to put this in. Constructor's not working. There, that should do it. Oh. Nice. Okay. Notice we added a little test in here for null. We should write a test for that. We had to get that in here to work, but let's write, we're going to do a press on nothing. Does not drag. Does not drag. So we're going to just leave this out. And leave this out. So this is like pressing on the background, clicking and dragging on the background. Still passes as expected. All right, another check we can do. We shouldn't do this if we're not using the left button. So test, press with right button does not drag. So again, we'll take this part out because we want to be over it. So we'll go back to this. So we did click on the tape measure, but we did it with the right button. And similarly, we did it with the middle button. So this is middle. All right, so we can do this check up here now. We can do, we'll do our, set that to true. We can start by saying if button is not equal to left, we're out of here. We don't need to set it. Great, cool. So now we've got all those tests passing. Another situation, remember we have those tools, right, up on the upper right. We only want this to work when you're in the tape measure tool. So let's go up here and we need to do our, we need to have that entity. So we're going to do a constant tools equals make tools. And we're going to go ahead and just tools dot set selected tool to measure. Now what we should do is take this out. If press does not drag, if measure tool is not selected. All right, so now we do this get our tools in here, and let's just set the tools to set selected tool. Let's set it to orbit. Now do a left. When we submit a move, we should expect it not to drag. That means over here, we're going to need our tools. We got to do a check. So go up here. This is a private. Tools, this. Now what we're going to do is we're going to do a check over here. So if tools dot get and we're going to get the, what's wrong? Oh, you know, this gets me all the time. I always pull in the Babylon tools, which is not what we want. We want these guys. Tools dot get tool measure is, or just selected, and we got to do a not on that. We return. So if the tool is not selected, we're out of here. Oops. All right. Now up here we got to pass in our tools. There we go. So the tool's not selected. We do it. All right, finally, we've done a lot of odds and ends. Let's start to check the parameters that are being sent to our use case and make sure that first off, we're selecting the right, we're passing in the right ID, and then finally, let's make sure that we're calculating our offset vector correctly. All right, so we'll start with, let's get one that does work. Press and drag on the tape to move. Yeah. We're going to check to make sure use case is called with the correct ID. So we do this, and we now expect use case to be called, well, we can do this. We're going to do this. Use case dot mocks dot calls 0. It's the first one that's passed in to equal tape 1. How's that look? Save. Oh, okay. So right now we're passing in just the IDs. So we need to get, let's change this to is dragging tape, and this is going to be a string, and we will set this to unstri. What? There we go. And this is going to be undefined. Otherwise, we'll actually set it to picked object. And now, oops, this is dragging tape goes here. There we go. There we go. Getting that. All right, let's get into the harder one. This is going to be the calculation of the drag. So let's talk through this. We have a mouse ray down. Okay, so that mouse ray is shooting straight down through 0, 0. That's what we start with. And it's going to hit at 0, 0. So fortunately, we can do some quick, we're going to create a second mouse ray for the drag. So we're going to do mouse constant drag. We're going to call it mouse 2. So it's going to go from mouse 1, the original one, the one that we did in our rig, which is running through 0, 0. And we're going to do mouse ray 2 is going to be our second part. And this is going to be, we're going to make a new parametric line. And we're going to make it from point direction. So the point, we're going to slide it off. So remember, we're looking straight down. So anything we'll just keep it pointing straight down. We'll just move it around in the world from where it starts. Now that point we're going to make, so we're going to call this constant mouse origin, mouse ray origin. And let's just have that equal a make vector 3. And we're going to push it in the x. Remember, this is in meters at this point, so we're going to push it in the x 1 meter, and we're going to push it in the y 2 meters. But that's in the z actually, because the planar coordinates, we're looking straight down. And let's just start our origin just above the y, just to have it in there. So it's, yeah, doesn't really matter. And then constant mouse ray direction is going to be a make vector 3, and that's just 0, -1, it's pointing down, 0. That's all that is. Now we can make a mouse ray origin. We need an equal sign. Mouse ray origin is going to be here. Something's still wrong. And mouse ray direction is down. So now what we've done is we've created this new mouse ray, and we're passing that in as our new mouse ray. So essentially we're saying the mouse went from shooting straight down through 0, 0, 0 over to shooting straight down through 1 meter, 2 meter. And it's going to collide with our plane. Well, we haven't talked about that yet, but it's going to collide with our plane at that ground level. Okay. What do we expect? We expect this delta to be this, to be that change, but in inches. So we're going to say constant x in inches is going to be, I think I have a thing to this, meters to inches for 1 meter, and because of this number right here, and then constant z in inches. It's going to be meters to inches, and it's going to be 2 because of this number right here. And then we expect, okay, we can do that down here. Expect, so then we got this, we're going to get this, so when we're going to send this vector to this use case, this drag tape use case. So we're going to have this constant, what's it called again? It's called something like drag delta is going to equal to drag. So this is the vector that was sent to the use case. Mock calls 0, and it's the second value, value that was sent. You know, it's like the second part of the signature. Over here, the first part of the signature is the string. Second part of the signature is this vector 3. And so this is what we're grabbing. We're grabbing this drag delta. And then we expect drag delta, and let's go ahead and cast this as vector 3. Now we expect drag delta dot x to equal x in inches, and we expect drag delta dot y, we don't drag in the up and down, and we expect drag delta z to equal z in inches. Okay, so now we have to do these 2 hits, if you remember this. So go back to this one. We got our drag, we're almost there. We have to take our hit 1 minus the previous hit. So we need to keep track of the previous hit, and for every drag event that comes in, we need to calculate the delta we did and then reset the previous hit. So next time we get a drag event, we will store that same hit. So we're going to be doing a raycast into a plane quite often. So let's make that into a function, and we're going to call that this. We're going to say we're going to do a private function. I'm just going to call it private raycast into plane, and we're going to give it the ray. The ray is going to be a parametric line, and we're going to hopefully send back it's going to be a vector 3, but it might be undefined because the raycast may not hit the plane. It may, like if you're parallel, it won't hit the plane. So we're going to do this constant. We have this thing called a pick plane. Well, we're going to make a pick plane called parametric plane. And I know because I made this, we want the parametric plane to be just the XZ or the ZX plane. So that's the working plane we're in. It's the plane on the ground shooting them. And then we do this return dot plane pick plane dot intersect the line, and that's the ray. There we go. So on mouse down, we need to store that initial place, because remember, we're getting a delta. We're doing a relative change. So we're going to have this thing called private previous hit, and that's going to be a vector 3. And it could be undefined because the first time around we don't have one. So now we're going to do this dot vector 3 previous hit is going to be equal to this what do we call this thing? Raycast into plane, and we're going to pass in this dot input dot get mouse ray. So this is the mouse ray that the input thing has. It's saying, okay, this is the last mouse ray. We're going to raycast into the plane. We probably need this in front of this. There we go. Now, if we don't hit the plane, we can't do anything. We don't have our initial spot, so we're going to bail out at this point. So if not this dot previous hit, return. So we're going to get out of there. All right. Let's do, so we get down here now, and then we're going to do this other one called constant current hit. It's going to be the same thing as this. Okay. Again, if we don't hit, we can't do anything. So if not current hit, then we're going to return. We're out of here. Can't do anything. Otherwise, we're going to do, what was our math again? We're going to do hit 1 minus the previous hit. So we're going to do constant delta hit delta. It's going to be hit current hit subtracting this dot previous hit. Okay, we got to do a quick check on here. Make sure we have a previous hit. Not previous hit to get this guy to work. All right, hit delta. Cool, getting there. So now we've essentially got this blue vector right here going from our hit 0 to hit delta. While I'm thinking about it, we need to go ahead and do this dot previous hit equals hit current hit. This sets us up for the next lap of delta of a mouse move. Remember this mouse drag? Well, this mouse drag is going to happen as you drag the mouse. So it's going to be little bitty increments, and we need to just keep track of the previous hit. So we're only doing a little bit of delta. Cool. So now we got our hit delta, but again, this is in metric. So this is in meters. So we need to convert it to inches. So we're going to have this thing called constant hit delta in inches equals make vector 3, and it's going to be hit delta dot well, let's start it at zeros and then we'll bust it out. Yeah, it just looked a little better. Now we're going to do hit delta in inches dot x is going to equal to hit, we're going to do meters to inches of hit delta dot x and meters, and then same with z. And, oops. There we go. Made it equal. Now, moment of truth. Did we do it right? Let's see. Oh my goodness gracious. This is why I love test-driven development. We did the math ahead of time. We laid it out. We knew what we were trying to get. And we just did a bunch of funky coding over here where there's a lot of possibilities of error. But we got it right. So that's good. That's real good. Okay. What else? What else do we need? Let's do a 2 drag. Let's make sure our delta is getting reset. So what we'll do is we'll drag it once, and then we'll submit another drag. Yeah, that's what we'll do. So let's do this. Ooh. We need to change this. Use case is called with the correct drag. All right, so we're going to do 2-step drag because it is possible that our delta, whatever we did up in here, maybe we forgot this line. In fact, let's comment this line because this is what will fix this test. So this test should fail. Okay, use case is called with the second drag. Okay, so we're going to press down with the left. We're going to do this first move. All right. Then we're going to do another move. So this time, so the ray origin, we went, okay, so we went, let's get our pen and paper out. Okay, so the first one, let me get my pencil down here. I got to draw these things out. So so first drag is at, so this is going to be 0, 0. We're just going to look straight down. So this is looking into the pick plane. Ray origin is at 0 or 1, 1, 2. So 1, we won't do Y. Y is up, and then 2. So this is 1. All right, and this is going to be that first delta. We're going to reset, and then let's do ray 2 down to here. And so in absolute coordinates, this is going to be, should have done those dots. Those dots make it hard to read. 1, 2, 3, 4. 1, because it's up 1. And then negative 2. And that delta is going to be, so this one was 1, 1, 2. So that delta is going to be, this delta is going to be equal to, let's see, it's going to be 3 in the x, it's going to be 0 in the y, and let's see, negative 4 in the y, in the z, because it's going down 4. Yeah, so that's what our delta should be in metric. Okay. Okay, so that means we'll keep our origin there. So that's our first move. Let's go ahead and we're going to clear our drag tape UC, mock clear. That'll reset everything because we're at this point we're at the previous test. We've moved the mouse. Now let's make our new ray. And we'll move it again. Mouse ray origin 2. Origin 2. It's actually 3 at this point. And what did we say it was going to be? It's going to be 4, 1, negative 2. 4, 1, negative 2. Direction, we'll keep the same direction. That's not changing. And we're going to do ray 3. And this is going to be from here. And we're going to submit this ray 3. And we got a bumper pixels because I don't really like that. Now, here we go. We're going to go. We got to get our, let's see, we expect it to be 3 and negative 4. So this should be 3 and this should be -4, and there we go. So it should fail because we commented this line. So we hope. Good. Now, let's see. See how good we are. Oh man, that's good, isn't it? Right on. Cool. I think that's about it. Yeah. I think that's about it. Geez, that was a long one. Let's call it. But look at what we've done. We have created a controller now for the mouse. And you can see these are very mouse specific things on mouse drag. We're looking at the mouse ray. There's a lot of stuff in here that maybe we should think about putting into the use case, like this check for the tool. That might be a little too specific for this controller. Maybe this controller shouldn't even worry about that. It just sends stuff to the use case, and the use case is responsible for that. That might be a good option. Same with picking a scene object. I don't know, that feels like you need to do that because, I don't know, both these things I kind of feel like you need to do, otherwise you're sending a bunch of data, you're doing a bunch of calculations that it's not going to be used. And so it's not like these calculations are heavy though. So I don't know, but you can imagine that what we would do is, you know, if we wanted to do this for a touch or for a stylus, we would pretty much use this same logic and form up ultimately this bit of information, hit delta and the ID that we're dragging, and that would kick off everything else. All the views and stuff would be ready to go. So we could swap out that or change or add more controllers to the system without affecting any of the domain. Well, technically this is in the domain, but without affecting more. So cool. All right, that's it.